Hello and welcome to another episode on computers. This episode will shine a light on the range of applications of computers in various fields like industrial, weather forecasting, biological and mathematical research. I'm Amrita Ghosh Kumar and the subject expert for this episode is Ms. Nazia Hussain, who is teaching in Bangalore University. Let us begin by looking at the use of computers in industrial houses. Businesses today have a wide range of uses for computers. Computers have been a necessity for industry not only in order to use their resources more efficiently, but also for a way of reaching a larger group of potential customers. As a result, IT or information technology jobs have been flourishing for some time due to the industry's reliance on computers for their daily operations. The role of computer in industry. Number 1, inventory tracking. Using spreadsheets and or databases, most businesses utilize some sort of computer maintained inventory tracking system. Number 2, payroll. From printing or depositing paychecks to applying raises and bonuses, industries have become very reliant on computerized payroll methods. Number 3, cash registers. Modern cash registers are often networked computer systems, allowing companies to maintain much more up-to-date and accurate transaction records as well as real-time inventory tracking. Number 4, websites. Most industries have been migrating towards the internet over the past 2 decades, resulting in the need for websites that require not only server space but maintenance and updates as well. Number 5, customer databases. Customer databases are used not just to track order information for clients but also to chronicle interactions to better serve clients in the future. Computer for graphics. Computer graphics have progressed significantly since the 1950s. We are now at a stage where photorealistic 3D images can be created using commercially available tools. We are in an era where 3D artists are in high demand and low supply, presenting excellent opportunities for those with a creative flair to build a successful career in the industry. 3D computer graphics are typically separated into 3 phases: modeling, layout and animation, and rendering. Modeling. The process of creating the shape of an object is known as modeling. This task is most commonly performed on a computer by an artist or an engineer depending on its purpose or by scanning real-world objects. Layout and animation. Objects need to be placed in a scene prior to being rendered. Animation determines certain aspects of an object such as how the object moves and deforms over time. Rendering. 3D rendering refers to the process of converting a wireframe into a 2D image with a 3D style image. One of the most comprehensive tools used in the 3D industry is Autodesk's 3Ds Max. 3Ds Max is very widely used. It was one of the tools used in the creation 3ds Max is suitable for every area of 3D computer graphics and is very easy to use. Computer-aided design. Computer-aided design was introduced in the shoe industry in the 1970s. Initially, it was used primarily for pattern grading. It enabled manufacturers to perform complex grading relatively easily and quickly. CAD systems or CAD systems today have been developed with a much wider range of functions. Logos, textures and other decorations can be incorporated into product designs of both the uppers and soles to help reinforce branding on all areas of the model. It automates routine procedures, increasing speed and consistency while reducing the possibility of mistakes. CAD data can now be used effectively for a wide variety of activities across footwear manufacturing business. CAD or CAM generates data at the design stage, which can be used right through the planning and manufacturing stages. The latest improvements in the CAD-CAM technology are graphic capabilities and interconnectivity have improved enormously. Software developments have progressively made systems more intuitive and easier to use. With 2D sketch and paint modules, a serviceable sketch can be produced and then color and texture can be added. 3D systems enable the last and design to be viewed from any perspective and several angles even simultaneously. Computer Information Technology. This program is designed to provide students with first-hand knowledge of the software, hardware and operations of personal computers used in business and industry today. Many aspects of the personal computer, including how it works, how data is processed, how to apply the functions to solutions on the job. The program consists of studies in the major operating systems, diagnostics plus configuration of computers and their related peripheral devices. Computers for weather forecasting. Computer-based weather forecasting depends on accurate collection of data from weather stations, airports, satellites, different sensitive devices all around the world. The computer depends on building a model of hot, cold air, dry and humid air, interaction and how these interactions are affected by land and sea temperature, seasons and so on. Once this is done, the data is collected on atmospheric phenomena over a region. The computer model then generates a forecast of how the air will change. The necessary parameters can never be measured with total accuracy and it is impossible to make a perfect representation of all the factors that affect weather. Some businesses, however, are so dependent on the weather that they need constantly updated information. Sparco Weather Forecasting Department offer analysis of live weather data and provides help to make business decisions based on weather forecasting. How are computers used in weather forecasting? Climate models. Climate models are primarily used to forecast substantial changes in the Earth's climate. Climate is the average weather conditions in an area for a prolonged period of time. Therefore, climate models use a combination of statistical and current data to provide a reasonable forecast. The CFS is one of the primary climate models used for forecasting planetary scale weather conditions such as El Nino, Madden-Julian oscillations or MJO and monsoons. Mesoscale models. Mesoscale models are mainly used to forecast the weather locally. Mesoscale in meteorological terms means the atmospheric conditions ranging usually from 2 to 20 km. Synoptic and climate models usually do not have enough resolution to forecast localized weather conditions such as single cellular thunderstorms and tornadoes. The North American model or the NAM is commonly used to forecast local weather conditions. Dynamic models. Dynamic models are the most sophisticated and costly tools used to forecast the weather. Dynamic models are advanced fundamental equations of the atmosphere to predict changes in the weather based on current conditions. Despite their efficiency, dynamic models can make errors during the initial runs. According to the National Hurricane Center or the NHC, the GFS, ECMWF, the NOGAPS, the UKMET and CMC are some of the dynamic models used for forecasting. Statistical models. Statistical models are primarily used to help meteorologists provide accurate analog forecasts. Statistical models use data from previous storms and weather conditions to help meteorologists get a better idea of how to track the current weather systems. Statistical models are commonly used to track tropical and mild latitude cyclones. If the dynamical model consensus is not reasonable, meteorologists often use statistical models to provide better forecasts. Efficiency of computer models. Although atmospheric computer models are effective tools for weather forecasting, they are not impeccably accurate. Computer models are usually less efficient during the preliminary runs. For instance, during the first stages of tropical cyclogenesis or tropical cyclone formation, computer models are usually not initialized enough to provide a reasonable forecast. Long-range forecasts, that is beyond a week, are usually less accurate because there are many atmospheric factors that can come into play beyond that time. Dynamic models are most accurate for 3 to 5 day forecasts. How are computers useful in national level weather forecasting? Computer-based communications are a powerful way of getting the latest weather information, and we are making good progress on building computer models. All weather forecasting begins with soundings of the atmosphere, that is measurement of T, RH, wind and pressure made with weather balloons. There is a worldwide system of balloon launches that gives meteorologists a snapshot of the atmosphere twice each day. Data from all of these soundings are entered into computers and transmitted via networks to various users, including the National Weather Service headquarters near Washington. Here the data is fed into some of the world's biggest computers, which are loaded with some of the world's biggest programs, computer models of Earth's atmosphere. Meteorologists are always among the first in line for the latest computers, because trying to describe and predict the behavior of the entire atmosphere is a big job. These computer models take in the recent soundings and begin making millions of calculations to predict what the atmosphere will look like in the coming hours, typically out to about 2 days. Once the model predictions are made, they are put on the computer networks for dissemination to local forecasters. Local forecasters use the model predictions in a variety of ways. To help fuel the forecaster's intuition as input to rules of thumb developed for a particular forecasting task, or as input for yet another computer model. Computers for biology. Computational biology, sometimes referred to as bioinformatics, is the science of using biological data to develop algorithms and relations amongst various biological systems. Prior to the advent of computational biology, biologists were unable to have access to large amounts of data. Researchers were able to develop analytical methods for interpreting biological information, but were unable to share them quickly amongst colleagues. How computers are changing biology. It is no secret that computer modeling is changing science. The ability to extract meaningful information from huge data sets and build sophisticated models is altering everything from astronomy to quantum physics. Yet, perhaps no discipline is witnessing more tangible benefits from computer modeling than biology. Computational biology and informatics have made it possible to dynamically map and analyze DNA and protein sequences, design and validate pharmaceutical drugs, and build models for artificial organs. Scientists are also combining research areas to explore new territories. Ron Shamir, a professor of computer science and bioinformatics at the Tel Aviv University, says a big part of the biotechnology revolution during the past decade has encompassed so-called next-generation sequencing, which facilitates ultra-fast, ultra-cheap sequencing of DNA. Since they are so efficient, these technologies take a step beyond merely sequencing genomes and are used as a measuring tool for various biological entities. Computers play a very important role in modern biology, collecting and processing signals detected by laboratory equipment, DNA sequences, CCD devices, spectrophotometers, and just about any other device that can be connected to a computer via an analog to digital converter. Tracking samples and managing experiments in industrial-style laboratories, example in gene sequencing centers. Smaller labs don't have the resources to invest in automated laboratory management, but using software to manually maintain lab notebook-style electronic records is rapidly becoming common. Storing data in public databases and, more importantly, public access to the database via sophisticated web searches and deposition mechanisms. Extracting patterns and rules from large data collections and using these observed patterns to characterize and predict features in new data. This is the core of bioinformatics, developing tools which can recognize pattern matches and feature signatures within an otherwise inscrutable data set. Annotation, using automatic computational methods to assign functional meaning to uncharacterized data and to create informative links between different data collections. For example, many annotation systems use automated sequence comparison searches to identify potential genes in new genome data. Simulation, using known information about a system along with a mathematical or physicochemical model to simulate properties of the system. This category is incredibly diverse, from simulating the motions of interacting protein molecules to modeling the flow of chemicals through biochemical pathways. Computers in mathematical research. Maths is one of the foundations of computer sciences. It is also one of the more crucial elements in computer sciences. Despite advanced mathematics not applied frequently, basic mathematics, most importantly algebra, is the main ingredient for a successful computer scientist. Many of the functions and operators in all programming languages require some knowledge in mathematics. For example, these operators include arithmetic, comparison, logical, assignment, and conditional operators. All of these tasks need mathematics for them to be useful and properly applied, especially the arithmetic and conditional operators. Computer sciences heavily rely on algorithms, which the latter in turn heavily relies on mathematics. Theoretical computer science strongly involves discrete mathematics. Discrete mathematics is basically the study of mathematical structures that are discrete rather than continuous, and so this theoretical branch of computer science involves a lot of mathematics in the form of graphs, algorithms, computational geometry, quantum computation, algebra, computational number theory, etc. In fact, the use of mathematics in computer sciences depends on the latter's department. Application of computer in mathematics. More mathematical applications in computer sciences are 1. Sets, 2. Probability, and 3. Boolean algebra. Many applications such as calculators, video games, and graphical applications are compelled to use of mathematics. For many programs to be created and written, logic is the central necessity, which in turn is mainly rooted to mathematics and mathematical principles. Hence, mathematics provides the right pathway towards success in computing. Formal methods is mathematically based technique for the specification, verification and development of software and hardware systems. It is another branch in computer science that depends on mathematics to a great extent, mostly algebraic manipulations and logic calculi. So, mathematics is considered a necessity for any successful computer scientist. All computer science applications require mathematics to some degree. To tackle the most challenging of programs, mathematics will be of huge aid. Computers in international trade. Modern technology usually refers to the combination of computers and communication devices which in the last several decades have changed the way in which we handle information. These changes are having a substantial impact on both the practice and the law of international trade, notably in the use of electronic documents to replace paper, the so-called electronic data interchange or EDI. EDI is commonly defined as the direct computer-to-computer exchange of standard business forms. It clearly requires a business process, because the key idea involved is the exchange of documents that allow a business application to take place without human intervention. Data processing is clearly necessary for application processing. Data communication is then necessary for the exchange to take place. It is the marrying of these three disciplines that allows the paperless trading that comprises EDI technologies. Information and communication technologies or ICT touch every sector of our economy. These technologies facilitate the sharing of information and ensure more effective delivery of services while eliminating the barriers of time and distance. With the innovation, competition and globalization movements, ICT is changing the way that people do business and communicate. ICT covers a long list of goods and services, including such traditional technologies as telephone and television, as well as more recent technologies such as cellular telephones and the internet. ICT goods are used to process information and to communicate by electronic means, while ICT services make these functions possible. The ICT sector includes industries which are mainly operating in the production of goods and services or in the implementation of technologies used to capture, process, transmit, receive or display data and information by electronic means. It comprises of 8 manufacturing industries and 15 service industries as classified within the North American industry classification. Services. For the purpose of data on international trade, services are grouped into 4 main categories: travel, transportation, commercial services and government services. Commercial services. This grouping encompasses all services that are not travel, transportation or government services. Commercial services cover a broad range of activities including insurance, management, royalties, fees and licenses, informatics and architecture, information, engineering and technical services, research and development. The same technology permits services to be offered in remote locations which previously would have required a substantial local presence. Effects of electronic data interchange in international trade. Electronic data interchange or EDI is commonly defined as the direct computer-to-computer exchange of standard business forms. It clearly requires a business process. Because the key idea involved is the exchange of documents that allow a business application to take place without human intervention, data processing is clearly necessary for application processing. Data communication is then necessary for the exchange to take place. It is the marrying of these 3 disciplines that allows the paperless trading that comprises EDI technologies. EDI plays a very important role in international trade from the last few years. The science of robotics will continue to change the way in which large cargoes can be handled and the way in which large carriers may be operated. More refined models of stock control, only possible with substantial computing facilities, will continue to change the pattern of stock replacement and consequently the pattern of stock movement and the international trade in goods. Computers used at remote sensing. Remote sensing or RS refers to the branch of science which derives information about objects from measurements made from a distance, that is, without actually coming into contact with them. Conventionally, remote sensing deals with the use of light, that is, electromagnetic radiation, as the medium of interaction. RS refers to the identification of Earth features by detecting the characteristics electromagnetic radiation that is reflected by the Earth's surface. Computer-based remote sensing techniques offer a unique chance to analyze and map the surface geology of remote arid environments in a relatively short time and at low costs. The role of computers in remote sensing. Geographical information system may be defined as the integration of computer hardware and software with spatially referred digital data so that storage, retrieval, manipulation, analysis and display all forms of geographical referenced information is possible. GIS is a computer assisted system that can input, store, retrieve, analyze and display geographically referenced information useful for decision making. Computers and multilingual systems. Multilingual systems refer to computer programs which permit user interaction with the computer in one or more languages, where the language can be selected dynamically either at the time of invocation of the program or subsequently during its execution. Typically, a multilingual system will permit users to interact with computers in their own mother tongue. That is all we have for you today. Hope you have understood the range of applications that a computer can be extended to. We'll see you again with another topic on computers. Till then, take care and bye-bye.